So, we discussed Bilbo best in the previous class. So, what we did was we took a one Bilbo configured as PRPG, that is pseudo random pattern generator, and we took some random logic. This was a 4 output Bilbo, and as a result we constructed some random logic. In this example it was a combinational logic, and we gave these inputs, and then we also took a second Bilbo which was configured as an MISR, multiple input signature register, and these inputs coming from the random logic, these were also 4 outputs. You could also do it like this. See, suppose this was a sequential circuit. Okay. So, of course, there was, I did not show you the reset and all that, reset clock, then this has a reset and clock. These resets are connected and these clocks are also connected. If this was a sequential logic with scan, maybe it has many scan chains. So, these are the scan in, scan out. So, this may be 4 scan inputs and 4 scan outputs. There is also reset and clock, of course. So, we could take our Bilbo here, configure it as PRPG, and the outputs can go as scan inputs to the sequential circuit. So, this is a sequential circuit, whereas here it was a combinational circuit, and I can have another Bilbo configured as a MISR. I am assuming that the sequential circuit has 4 outputs. So, those will feed these Bilbo. This also has a reset and a clock. All the resets are connected, and all clocks are connected. I am not going to show all that because it becomes very complicated. So, once we reset the circuit, we can apply, we have to load the, unfortunately this Bilbo, you see initially we have to apply a seed. So, loading the initial seed is to be done, then followed by a certain number of clocks, and then we can see what is the signature here, and if the fault exists in the circuit, the signature is expected to be different. As I explained to you earlier, in this 4-bit Bilbo, there can be up to 16 signatures were possible. So, we can have 0 0 0 0 or 1 1 1 1. And The good circuit signature and the faulty signature are expected to be different, but there is a small chance that they are the same. Okay. In that case, we say aliasing occurs. So, aliasing means good signature is matching with the faulty signature. So, just like somebody can forge your signature, okay. Our signature should be such that it is difficult to forge. In the same way, this Bilbo, if it is only 4 bits, then there is not, there is a fairly good chance that a faulty and a good signature will match. But if I am willing to take a much larger Bilbo, let us say 8 bit, 16 bit, then the chances are, and as I explained to you earlier, we could also include a phase shifter. I did not do it in my experiment. Okay. So, I could use a phase shifter here, that helps. So, it helps to reduce the correlation between two outputs of the Bilbo, and that helps. Some people will also put a reverse phase shifter here. Suppose a sequential circuit has many outputs, then we can sort of take some of those outputs, XOR them together and feed it to the input of the Bilbo. Okay, suppose a sequential circuit has many outputs. So, we could maybe take these two guys and maybe these two guys, maybe these two guys, and that way we will have only 3 outputs. If we have a 4-bit Bilbo, then we will need one more, maybe we can take these two guys. So, now we have reduced it to 4 bits. This is a sequential circuit, 5 outputs, no 6 outputs I think. 1, 2, 3, 4, 5, 6 outputs. Through this XOR, we have been able to reduce it to 4 outputs. And here also we can do the reverse. So, this is the Stumps architecture, STUMPS. Okay. This is the Stumps architecture, which I believe it is, yeah, I can see that this Stumps architecture looks like this. Okay. PRPG, phase shifter, scan. Okay. I wonder if somebody has explained who invented Stumps architecture, etc. I suspect it is either IBM or okay. So, this is our LFSR, let us say. So, if you put all zeros, unfortunately, it will start producing 0 0 0. Okay. If I put 0 0 0 here, the XOR of these two is 0 and it will come here and it will get stuck. Okay. But if I can recognize that it is all 0 through an OR gate, and if that can be fed back to this guy, I think that is how it works. So, we will put 0 0 0 here. So, when we reset it to all zeros, this NOR gate will produce a 1. So, as a result, this will get a 1. So, we will get a 1 into the leftmost bit. Okay. So, when initially we are in the 0 0 0 state, then in the next clock this XOR gate would have generated 0 XORed with 0 XORed with 1, right. So, that will come here, right. Once the input, these inputs have become anything other than 0, the NOR gate will produce a 0. Okay. 0 XORed with 0 is 0, 1 0 1, 1 1 0, 1 1 1, 0 1 1, then 0 0 1. See, then unfortunately it will go off into, see, it will get you started. Okay. So, if you start with S0, that is all 0 state, it will go to S1, I am sorry, S4, then it will go to S2, then it will go to S5, then it will go to S6, then it will go to S7, then S3, then unfortunately it goes, then it goes to S1, and after that it is not going to 0 0 0 state. So, it directly goes off into the 1 0 0 state, it will go here. It is still better, it is not going to refuse to work, right. If we forget to load the seed, or rather if we load 0 0 0 as a seed, the previous guy used to get stuck here. If I do not have this NOR gate, it will get stuck here. But there is a clever way to even include 0 0 0. Okay. Okay. I think I will give this as an exercise. Generate, or rather design an LFSR of n bits which also generates the all 0 state. So, it has all the 2 to the power n states. That makes our life easier. Okay, we do not have to worry about initially loading. See, in our Bilbo register solution, unfortunately we have to first load the Bilbo with a seed. Only then we can start operating the Bilbo as a PRPG. But if you could simply reset the Bilbo and put all 0 as the initial seed, it makes life a little bit easier. Or put some random state, you could see when the flip flops come up, they could be in a random state altogether. When you power on, they will be in a random state. So, then the output will look sort of completely random. We do not know what state we started with. So, I will give this as an exercise and you can try it out. You will find the solution in the literature. Okay. I mean, if you search hard enough, you will get the solution. It is also described in the book by Van de Goor. So, Van de Goor was a professor in Netherlands, and he worked a lot in memory BIST. Okay. And in his book, he gives you that solution.